We're here at DVD 2018 and I'm speaking with Mike Jones, Chief Engineer, Special Applications, Alcon. Mike, brakes.
Yeah.
Every vehicle has brakes, everybody knows every vehicle has brakes. I mean, people know very much about brakes, particularly within the defence sector. Could you tell us a little bit about Alcon, its involvement with brakes, and where one might find Alcon brakes within the defence sector?
Alcon started off pretty much in motorsport, and then we've taken the mentality of how we develop things into heavier vehicles, and that's how we've got into the defence industry. Our first two contracts were with BAE for the CVRT and with Ricardo for the Rimmick Defender, and then we've developed through Supercat on the Jackal and Coyote, and the latest announcement that we've got is that we're on the Patria's AMV XP 35-ton vehicle. So it's a bit different from where we started with motorsport, but basically what we're producing is a hydraulic clamp that stops vehicles, and it's using the basic physics to get the sizing right.
And you say hydraulic clamp to stop a vehicle, that's disc brake, yes, pads in a caliper. There are, of course, drum brakes.
Yes.
For those that may not be familiar with the technical differences between the two, could you talk us through the differences between the drum brake and the disc brake, and the pros and cons of each type?
Yeah, I think with any braking, it's finding the most suitable brake for the application. So a lot of marketing will tell you that you shouldn't have drum brakes on vehicles because car magazines and TV programs will often show great big disc brakes on the vehicles and almost sneer at drum brakes. Drum brakes are still very good for low speed vehicles and lighter weight vehicles. The issues with drum brakes are temperature related, where if you get too much temperature into the drum you can end up with brake fade and you can end up boiling the brake fluid. And also on some applications as well, if you're getting them too wet, then you'll end up with not having much braking when you apply your brakes soon after they've got wet. But otherwise they do have their place. So basically with a drum brake, you put hydraulic into a cylinder which then pushes out shoes, and the shoes move out into a drum, and it's that does the clamping. With a disc brake, it's putting it into a caliper which basically pushes pistons, which pushes pads that stop a disc from rotating. So both are just different methods of stopping vehicles, and they're both very valid. The trick is choosing the right technology for the right vehicle.
And when it comes to disc brakes, we hear of air brakes, air over hydraulic, and so on and so on. Again, what's the differences between all the various types, and is one better than the other?
I think with all braking, there's not one that's better than another. It's finding the most appropriate brake for the application. So when you think about road cars will generally have hydraulic brakes that are actuated, really connected with the pedal and the foot. So the foot will put onto a brake pedal that will go through a master cylinder which pumps the fluid to the brakes, and it's that stops the vehicle. In order to get the pedal efforts light, you have a servo, and on road cars it's hydraulic, it's vacuum assisted for the servo to be able to reduce the pedal efforts. There's a limit to what vacuum servos can actually legally apply. There are failed situations that we have to take into account, and if the engine cuts out, you have no servo assistance and you can't press too hard on the pedal. So the limit for that kind of brake or that kind of brake system, it's generally when you get into 6 or 7 tons, then you need to choose to go to either air over hydraulic or air brakes. Again, one is not better than the other. It might just be for a particular application it's better to use the hydraulic brakes, or it might be better to use the air brakes. It depends on the configuration of the vehicle.
And a further technical question, if I may, materials. I mean, one assumes that the disc is steel,
yeah,
but I'm sure it's not just steel.
Yeah.
And pads can of course be made of a number of different materials, perhaps once upon a time even asbestos.
Yeah.
What are the materials today?
Disc materials, we haven't gone away from cast iron, so brake drums and brake discs, grey iron is still the best material for a brake disc. On our motorsport and on some of our high performance road applications, we're using carbon ceramic, and that does give you the advantage of having a much lighter corner assembly. And it gives you every bit as good a braking as cast iron, but in the majority of applications cast iron is extremely good, and it's difficult to find something better. With the brake pads, because years ago it all started off with wooden blocks, and then somebody came up with the idea of when they saw that they'd got gloves that were made of asbestos and it was better than wood, they actually put those, compressed them and put them into brake pads, and that was the modern brake pad out of asbestos. What we use now is not too different in the makeup, it's just taken out the asbestos, so it's a moulding or a pressing of various materials that is configured to give the best friction for that application. And again, it very much depends on the application as to if you want high performance in motorsport, you have a high friction pad that may have a high metal content. If you want durability and long pad life, you'll end up with a lower friction pad that has less metallic content. What we put on our armoured and military is it's trying to get the best of both worlds, where you still get very good wear resistance, but you get a very reasonable pad friction.
Excellent. Thank you very much indeed.